Welcome friends in lecture 4, lesson 8, motion. Now today's lecture we are going to learn the different types of graphs, representation of graphs of motion. First graph we will start with distance time graph. Now distance time graph, as you are seeing two graphs with distance and time. First graph that you are seeing is a straight line. Now on the y-axis we have taken as distance, on the x-axis we have taken as time. So as you are seeing the straight line, that means as if the distance is increasing, the same way the time is also increasing. So every time the distance and time increases simultaneously, like 10 meters in 10 seconds, so 20 meters in 20 seconds, 30 meters in 30 seconds, 40 meters in 40 seconds of time. The same way the continuously increase is in meters is with respect to same amount of time, right? So as you are seeing, the straight line shows the uniform speed. That means the speed is not changing with respect to time. In the second graph that you are seeing, the unevenness or the sinusoid formation is just because that every time the things are changing. That means the distance is not constant. For a particular unit time, you are seeing that the distance it is been traveled is quite different, right? So in initial case it is slower, and then it is suddenly rising, and then again it is slowing down. So you are seeing the different forms. It is not a straight line, and it can be any form, but not a straight line. That shows that it is an non-uniform motion, because it is changing with different meters in different second of time. That means it is not uniform. The second types of graph is velocity time graph. Now in the same way, if you see the velocity time graphs also, on the y-axis we have taken velocity, on the x-axis we are taking as time. As you are seeing is an acceleration. In that we were seeing the change of distance with respect to time as velocity. That means meter per second likewise. In case of velocity time graph, there is a change in velocity with change in time. That shows, before last lecture we have learned, that is known as an acceleration. So the line that is shown is in straight form shows acceleration, right? So acceleration is uniform, so that shows the uniform acceleration. And as you are seeing in the other graph, the y-axis is velocity and x-axis is time, but the graph is not uniform again, and it is changing with respect to time. That means the velocity is not constant. It is initially lower, then it increases suddenly, then again it changes. So the velocities is quite different with a unit time. That means the velocity is not uniform, and with that non-uniform velocity, it is a non-uniform acceleration. In the third graph that you are seeing, a blue mark is there in between, and you are seeing a straight line that is of velocity. On the y-axis we have taken as velocity, on x-axis as time. So if you are seeing the velocity is 40. Now every point of time, that is 2 seconds, 4 seconds, 6 seconds, 8 seconds, you are seeing that the velocity is remaining 40 only. That means if the velocity is not changing with respect to time, you can say the velocity is uniform. It's a uniform velocity, but the acceleration is 0. That means the velocity is not changing. If it had been a distance with respect to time, that means the distance is also not changing with respect to time. That means you are standing somewhere. That means distance, the velocity is 0. In this case, the velocity is not changing with respect to time, it shows a straight line. That means here the acceleration is 0, and it is not changing with respect to time, constant velocity, rather you can say the other way. Now the graphs that you are seeing, which is an enclosed with a pink color mark, right? So v1 velocity is initial velocity and v2 is a final velocity, and time t1 for initial velocity and time t2 for final velocity. You are seeing a straight line graph, and if you want to find the distance from this particular graph, you see the pink color trapezium which is formed can be taken into consideration. The area of trapezium can be taken into consideration for finding the area of that particular, distance of the particular speed, right? So what is the distance covered for that particular initial and final velocity can be found with respect to this pink color graph, right? So thank you for this particular lecture.